Okay, so this video is going to feel a little bit weird because I'm going to work an example that is new and probably a little bit closer to what the exam question will be like. And I'm going to go through it fairly quickly. And then I'm going to splice in the old video because we've already seen this process before with fractions. So I'm going to splice in that example where I more carefully or more slowly go through each individual step. So if this is too fast for you, the second half of this video would be a good one to review, and then maybe go back to this because this is a valuable example. So I want to solve this inequality, and there's a couple of ways to do it. One is that if you have a fancy graphing calculator, you can graph it and then kind of look at it and describe the regions. Or if we're going to use the concept that we've seen before / later in this video, we can first isolate, well, not isolate, get 0 on one side of our equation. So to do that, I would subtract 4x from both sides. I would subtract 12 from both sides. And the whole reason to do this is once I've set this up, now I can factor. So two things that multiply to get me -12, add to get me -4 are -6 and 2. So that's my factor form. And then I use these two factors to identify my critical points. And I do that by setting each factor equal to 0 and solve. So x minus 6 equal to 0, I would add 6 to both sides, get +6. X plus 2 equal to 0, I would subtract 2 from both sides, get -2. So those are my two critical points, which that means that those are the points where my graph will start to do things. It'll either change signs or maybe it possibly would bounce off the graph. But those are kind of the points I need to examine to find out when my function is going to be greater than 0. So now I kind of set up the whole number line. I add my two factors to the left of my number line. I add my critical points on my number line. I put these dashes, which aren't really technically mathematical, but they break up my region. And then I just pick points in each region and kind of compare it to my factors. So to pick a point less than -2, let's say -5, that will make my first factor negative. -5 plus 2 is -3. And my second factor negative. -5 minus 6 is -11. And so the next region, let's pick 0, make my positive factor positive, or my first factor positive, and my second factor negative. And then for the last region, let's pick like 8. 8 would make my first factor positive and my second factor positive. And now I kind of just total each region. Negative times a negative is a positive. Positive times a negative is a negative. Positive times a positive is a positive. Now, I look back at my original equation, or maybe the third equation, or third inequality that we see, and I want to find when my graph is strictly greater than 0. So I look at these three regions. I don't want to describe the middle region because it's negative, but I do want to describe the left region and the right region. And so once I do that, what I will get is my function will be greater than 0 when x is less than -2 and greater than 6. So interval notation would be -infinity up to -2 parentheses, because again, my inequality is just greater than, it's not greater than or equal to. And then union 6 to infinity with parentheses. If I were asked greater than or equal to, then I would have brackets on my two numbers. I would still always have parentheses on infinity because I can't touch those values. And so now the next video, or the video that we've already recorded, is going to start. Okay, this section is fairly short, which is good. In fact, we're only going to go over one process. The only issue is that process is kind of fairly involved. And so if we're solving rational inequalities, what we're going to want to do is we're going to want to have 0 on one side of the equation. So if that hasn't happened in an equation yet, we need to move everything to one side. The second thing we need to do is we need to factor anything if it isn't already factored. So kind of dealt with those first two steps already in this example. I have 0 on one side of my inequality, I have my expression on the other side, and everything is fully factored. And so what I'm going to do is I'm going to find my critical points. And I find my critical points by setting each of the factors equal to 0 and then solving. So my two critical points are 2 and -4. Now, since we're dealing with an inequality, we're going to pull out that number line again and kind of see what this will look like. And on this number line, I'm going to set my two factors to the left side of the number line, just like that. And I'm going to put dotted lines on my critical numbers. Those are going to kind of divide things into the region. And that's a critical number, and this is true in calculus as well, is it's kind of where things are going to change or things are going to happen. And so we're going to determine what's going to happen in between those and outside of those points, because we know at those dotted lines things are going to change. The next step is to pick a number in the region, and this could be any number. It just has to be within the region. So I chose for my left region -6. I chose for my middle region 0. I chose for my right region 3. You could have picked -10, -2, and 30. As long as you're picking something that falls into that region, the process will be the same. So what we do now is we determine the sign of each of our factors using that number. So we picked -6 for the region that's the furthest left on that number line. Well, -6 plus 4 will get me -2. -6 minus 2 will get me -8. And then I'm going to put those negative signs, if we look back over to the number line, I'm going to put those number signs in those regions next to each factor. And the truth of the matter is, those numbers don't really matter. All I'm concerned about is the sign. So that's what I was talking about. If you picked a different number, like -10, you'll get different numbers, but you should still get that the top factor is going to be negative in that region, and the bottom factor is going to be negative in that region. And now I repeat that. So for my middle region, this space between those two dotted lines, I'm going to pick 0. And I'm going to plug that into x plus 4. That gets me +4. I'm going to put a +4 on my number line over there on the left side. 0 minus 2 gets me -2. I'm going to put a negative sign over in my number line. And one more region I have to cover. I'm going to plug in 3. First factor gets me 7. I put a plus on my number line over there in that spot. And 3 minus 2 gets me 1, so I put a positive sign in that spot over on the number line as well. Now, next step is to figure out kind of what's happening overall in that region. And so for my first region, I have a negative times a negative. That will get me a positive. I have a positive times a negative. Well, that would get me a negative result. And a positive times a positive will get me a positive. Now, we did this long and involved process, and I probably should have explained why we're doing it, but I'm going to go ahead and do that right now so we can kind of tie everything together. The question is asking, when is x minus 2 over x plus 4 greater than or equal to 0? Well, I determine kind of the behavior of each of these regions, and so I want to know when that is bigger than or equal to 0. So I look back over at my number line. Well, it's bigger than or equal to 0 in 2 spots. Everything less than -4 and everything bigger than 2. And now all I have to do at this point is I have to describe that region in interval notation. So the leftmost region is from -infinity up to -4. And the rightmost region is 2 up to +infinity. Now you might be asking yourself, well, it's weird that one of the numbers has a bracket and the other number doesn't have a bracket on it. What's happening there? Well, if you look back at the expression, I see that if I plug in -4 into that expression, that would mean I was dividing by 0, which I'm not allowed to do. So even though overall I'm dealing with a greater than or equal to, which generally means that I have brackets on every number, I have to be careful with the fact that I'm dealing with rational inequalities. And so anytime that your factor is on the bottom, that critical number should not have a bracket on it.